Structural vulnerability and triggered failure between borderline personality disorder and stroke Part 1, number 1585, the 2nd of April 2026. Gerald C. EclaireMD Foundation. Category: Psychology and Neuroscience. Preface: I spent 18 years, from age 16 to 34, studying mathematics, computer science, artificial intelligence, engineering, biomechanics, mechanical, structural, civil, and ocean, and business management, earning a total of 7 academic degrees. After completing my formal on-campus education, I founded 7 high-tech and engineering companies. Many of these ventures failed, but the accumulated experience eventually led me to become one of the top-performing CEOs on Wall Street by age 48. However, the long years of struggle and the intense stress from continuous competition eventually contributed to the deterioration of both my psychological and physiological health. I then began a long period of self-study, focusing on psychology for approximately 9 years and internal medicine for approximately 17 years. A total of 26 years of continuous independent learning and research outside the traditional academic environment. I hope this manuscript presents a clear systems-level insight that borderline personality disorder (BPD) in psychology and stroke resulting from chronic diabetes in neuroscience and pathophysiology follow a similar structural progression. Long-term stress gradually reshapes biological systems, neural circuits or vascular walls, and this accumulated structural vulnerability increases the chance of nonlinear failure when an acute trigger occurs. Introduction: a systems view of shared mechanisms between psychology and physiology. Over 44 years of learning and observation, I gradually noticed that certain patterns seen in psychological conditions, particularly borderline personality disorder, appear to share similarities with patterns observed in chronic physical diseases, especially stroke and neuroscience. During the past few days, this idea became clearer to me. I realized that the similarity does not lie in the detailed biology of the diseases, but in how living systems respond to long-term stress. This realization allowed me to approach the subject from a systems viewpoint rather than from the traditional boundaries of psychology or medicine alone. This systems view of a single problem, or the relationship among multiple disciplines, developed from my 44 years of academic learning and 20 years of industrial experience. Long-term borderline personality disorder (BPD) and brain stroke caused by long-term diabetes damage appear to belong to completely different medical fields. One involves emotional response and behavior, the other involves blood vessels and brain injury. However, when viewed from a broader systems perspective, both seem to follow a similar process. Long-term stress gradually changes structure, gives tolerance, becomes lower, gives an external trigger, occurs, gives sudden event, appears. This type of process is commonly seen in engineering. Repeated stress may slowly weaken the internal structure of a material, such as a reinforced concrete and steel bridge subjected to heavy truck traffic over several decades. The material may appear normal for many years, but its ability to tolerate additional stress has already been reduced. Eventually, a load, such as a hurricane or an earthquake, that would not damage a healthy structure becomes enough to cause fracture or collapse off bridge. Human biological systems behave in a similar way. In psychology, repeated emotional stress may gradually increase sensitivity of neural response systems. In physiology, long-term metabolic stress may gradually reduce flexibility of blood vessels. In both situations, the system adapts to stress, but the adaptation may also create hidden weakness. The triggering event often appears sudden, but the underlying structural changes have usually been developing gradually over many years, often without being noticed. In borderline personality disorder, early life stress such as inconsistent care, neglect, abandonment, emotional or physical abuse, or chronic fear may influence how a person's emotional control system develops. Particularly during childhood, repeated emotional stress strengthens certain neural pathways, making the nervous system more sensitive to perceived threats. As a result, a relatively small interpersonal conflict may produce a strong emotional reaction. The reaction may appear excessive, but it reflects long-term change in neural structure. In chronic diabetes, long-term exposure to high glucose gradually damages blood vessel walls at the cellular level. Biological processes such as inflammation and protein damage reduce the elasticity of arteries. Blood vessels become stiffer and less able to absorb pressure changes, such as cerebral calcification. After many years of gradual damage, a sudden increase in blood pressure may exceed the tolerance limit of the vessel wall, leading to stroke. Although psychological trauma and pathophysiological vascular disease involve different organs and biological processes, both appear to follow a similar structural progression. Particularly when viewed from a systems perspective, long-term stress changes structure. Changed structure lowers tolerance. Lower tolerance increases sensitivity to triggers. Trigger reveals hidden weakness. The triggering event alone does not explain the outcome. The condition of the system, shaped by many years of exposure, plays a major role in determining the final response. Two people may experience the same trigger but produce very different outcomes, depending on their long-term structural condition. In cases where a small trigger results in a large response, it is because the system has already been weakened over a long period of time. My intention is not to suggest that psychological disorders and vascular diseases are identical. The biological mechanisms remain different. Borderline personality disorder mainly involves neural pathways related to emotional regulation, while stroke mainly involves blood vessel structure and blood flow. Either through blockage or rupture. The similarity lies in how living systems adapt to long-term stress exposure. Long-term stress leaves biological effects in the human body and brain. These effects accumulate slowly and may reduce the ability of the system to tolerate additional stress in the future. Understanding this shared structural pattern may help explain why certain health events appear unexpected. In many cases, the final trigger is only the last step of a long process. In simple terms, long-term stress changes structure. Changed structure reduces tolerance. Reduced tolerance increases sensitivity to triggers. As a result, a relatively small trigger may produce a large outcome. This system's viewpoint may help connect psychology and physiology through a shared understanding of how long-term stress influences system behavior. Section 1. Psychological pathway. How early stress shapes later emotional response. A borderline personality disorder (BPD) is often associated with early life stress, especially during childhood when the brain is still developing. Common long-term stress conditions may include lack of stable emotional support and constant parenting neglect or abandonment, verbal or physical abuse, chronic fear or insecurity during childhood. The brain builds important circuits that regulate emotions and decision-making. These circuits help a person interpret situations and control reactions. 3 brain areas play key roles. Amygdala deep inside the brain, near the side above the ear, detects danger and emotional. 3 hippocampus inner brain area near the amygdala helps interpret past experience and memory. Prefrontal cortex front part of the brain, behind the forehead, helps control impulses and regulate emotions. When a child experiences repeated stress, the brain adapts in order to survive in that environment. The nervous system becomes more sensitive to potential threats. Repeated emotional experiences strengthen certain neural pathways. Over time, the brain becomes trained to expect danger. As an adult, the person may react strongly to situations that resemble earlier experiences. Even a small interpersonal conflict may activate strong emotional responses because the brain has learned to interpret similar situations as threats. The reaction may appear sudden or excessive, but it reflects long-term structural adaptation. In other words, a small trigger may cause a strong emotional reaction. The response is influenced by neural pathways formed over many years. This is part 1.